Alright guys, you have a quiz tomorrow. Today is a review. You have your review sheet. You can do it on your own and check your answers with the key later. You can do it with me through the video, however you want to use this. Use it to get ready because yes, you do have a quiz tomorrow. I will see you on Monday after the wedding. And your quizzes will not be graded, but we'll move on. So here we go. To review. First thing, what is the equation of the vertical asymptote for the function? Well, before I do anything, I need to be able to factor and simplify our function. So my top is going to stay x minus 2, but my denominator can be factored, because that's a difference of squares, to x plus 2 and x minus 2. After I do that, I simplify what I can, and I notice that they have a shared factor of x minus 2. So they cancel out. We're left with 1 over x plus 2. Now I can answer the question. Vertical asymptote can be found in my denominator. So we're going to look with what's left. Make that equal to 0. So x is going to equal negative 2. So our vertical asymptote is going to be the line x equals negative 2. Next one is asking me for a horizontal asymptote, okay? Well, with that one, we're looking at where the highest power is. And in this one, I noticed that they have the same power. Our numerator has a power of 1, so does my denominator. So what do? We divide the leading coefficients out of each. So we're going to do 3 over 2, which stays 3 over 2. So our horizontal asymptote is going to be y is equal to 3 over 2. All right, what is the removable point of discontinuity of the function? Very fancy for where do I have holes or breaks. So again, factor this function first. So we have that can factor into x plus 4 and x plus 1. Our denominator, I can take a 3 out of both of those. I'm left with x plus 4 in my denominator. So a hole or a break comes from any common factors that cancel out of both pieces. I notice I have an x plus 4 in my numerator and my denominator. So we're going to make that equal to 0. So we have x is equal to negative 4. So we're going to have a hole or a break at x is equal to negative 4. All right, number 4. All right, so this all goes together. Number 4, we have a function, wants to know where our discontinuities are. Then we're going to specify which one is which, and then we're going to graph it. So again, before I do anything, I have to factor my function. So my top is going to factor, let's see here, multiplies to give me negative 6, adds to give me a positive 1. That's going to be positive 3 and negative 2. All right, our denominator, that's a difference of squares. So we're going to have plus and minus 3 down here. All right, I can simplify this because they both have a plus 3. So I'm going to simplify it. Cancel those out. We are left with x minus 2 over x minus 3. All right, now I'm going to answer my questions. All right, what values discontinuities are we going to have? So my denominator shows me that x is not allowed to equal 3 or negative 3. And then the powers has the same, so we also know that my y is not allowed to equal 1. So we're looking for asymptotes and holes. Those are all the pieces that we cannot include in my curves in my graph. So now we're going to identify each. All right, so I'm going to start off with our vertical asymptote. Vertical asymptote comes from what's left over after the canceling. So that's going to be the line at x is equal to 3. That's what would make that piece 0. That is not 3, is it? Here we go. 1, 2, 3. Then my horizontal asymptote comes from the powers. They were the same, so we did 1 over 1. So our line there is y equals positive 1. So remember, asymptotes are the lines that we're going to approach. We're going to get real close to, but we're never going to actually touch it. And then we have a hole. With this one, we have a hole. There we go. We have a hole in this function where we crossed out the common terms. So when we draw it, we're going to have a hole at x equals -3. All right, so let's graph my pieces. I'm going to make a t-table to help me plot some points. So here we go. Here's x and y. All right, we know our vertical asymptote is at 3, so I'm going to go a little bit below and a little bit above. So I'm going to do, let's do 0, 1, and 2. There's the vertical asymptote, and then I'm going to go above it. Let's do 4, 5, and 6. Okay. I'm going to use my graphing calculator to help me figure out my missing values. Remember, when you type this into your calculator, you can do the original or you can do the simplified. It's up to you. I like to type in the original function every time. When you do not forget your parentheses. So when I type this in my calculator right now, I'm going to type in, I'm going to go to the y equals button. I'm going to do parentheses, x squared plus x minus 6, close parentheses, then divide parentheses, x squared minus 9. So I always like to type in the original, just so I know I don't make any mistakes. So type that in your calculator and get your y values. All right, so my t-table on my calculator gave me these functions out of it. You could also plug in x values. Remember, this piece in the middle shows us our vertical asymptote of 3. We can't be equal to 3. So a little bit above, a little bit below. So here we go, 0 and about 0.67. 1 and 0.5, 2 and 0. So we know my first curve will be in this quadrant. That's quadrant 3. We know that means our other curve has to be diagonal from it. So over here, we're going to have 4, 2, 5 and 1.5, 6 and 1.3. Notice they get really close to the asymptotes, but we cannot touch it. All right. So we have our curves over here and on this side. Remember over here, though, -3 is going to have that hole. So I got to make sure when I cross -3, I need to stop. 1, 2, 3. Make me a hole. And then keep going with the rest of my curve. All right, that is where we have a break in our rational function. You can draw the hole. If you want to put an obvious break in your graph, you can. I like to draw the hole, though. It's more obvious. All right, next one. All right, what is the equation of the vertical asymptote? All right, again, before I answer this question, we need to factor if possible and use our simplified fraction. So my numerator is not going to change, but my denominator can be factored. So we're going to have x minus 3. Factor this, it's going to be x minus 3 and x plus 1. The x minus 3's cancel. We're left with 1 over x plus 1. So now I can see that my vertical asymptote comes from my denominator. So our vertical asymptote here is going to be x is equal to -1. Remember, because you make this equal to 0 and we solve. So that's our vertical asymptote. All right, number 6. What is the removable point of discontinuity of the function above? Okay, so removable point, remember, very fancy for just what is the hole. Okay, so what's the hole or the break in the graph? And that was the piece that we canceled out. So we're going to take x minus 3 equals to 0. So we're going to have a hole at x equals 3. All right. So make sure you know your vocabulary, what they're asking you to do. All right, number 7, what is the equation of the horizontal asymptote? All right, horizontal asymptotes, we're looking at who has the highest power. Okay, so I look at my x. They both have a power of 1. They have the same power, which means I take the leading coefficients, which is 2 and 1, divide them, so we have a horizontal asymptote at y is equal to 2 for this function. All right, number 8. Identify any specific discontinuities. All right, so it's asking for any of them. So both my asymptotes, vertical, horizontal, and it wants to know any holes that we might have. So again, first thing we do is we factor. My numerator, it can be factored. I can take a 2 out of both, so it's 2 times x minus 2. My denominator can also be factored. This is going to be x, looks like it's plus 3, and x minus 2, because 3 times negative 2 gives me negative 6. 3 minus 2 gives me a positive 1. All right, there are some pieces that we can cancel. So we are left with just a 2 over x plus 3. All right, here we go. We have a vertical asymptote from my leftover denominator. Make that equal to 0 and solve. So that's going to be at x is equal to negative 3. We had a hole this time. The hole came from the piece that was canceled out. So here we're going to have a hole when x is equal, oh, forgot my at, hole at x is equal to 2. And then my last is going to be a horizontal asymptote if I have one. Look for my power. Looks like my denominator this time has the highest power. So he's going to reach up and he's going to hug my numerator. So our horizontal asymptote is going to be 0. So y equals 0. The bottom one is greater. He's going to reach up and hug the top. So making a 0. Okay. Same thing again with number 9. It wants them all. So same process. We're going to factor. We have a difference of squares up here. So x plus 3, x minus 3. Denominator, let's see here. It's going to be x minus 3 this time. And x plus 1. Negative 3 times 1 is negative 3. Negative 3 plus 1 is negative 2. Looks like these pieces cancel. They're common factors. We are left with x plus 3 over x plus 1. All right, vertical asymptote comes from our denominator after we have simplified. So we have x is equal to negative 1. That is our line that we cannot touch because we cannot be equal to 0 down there. My next one is a hole if we have one, and we did have a hole this time. It was the pieces that canceled. So our hole is at, what did we cancel? X minus 3. So it's when x is equal to positive 3. All right, last but not least, our horizontal asymptote. We're going to look to see who has the biggest power in our function, and it looks like they are sharing. They both have an x squared. So we're going to do their leading coefficients. They both have a 1, so 1 over 1 leaves me with just 1. Okay. Last one, number 10. Well, the last one of these kind, and then we're going to start graphing some. So number 10 is asking me the same. So again, factor. Numerator can't be factored. It's already as simple as it's going to get. So my numerator is going to stay x plus 1. Our denominator, though, is going to be x plus 3 and x plus 1. 3 times 1 is 3. 3 plus 1 is 4. All right, which leaves me with 1 over x plus 3. Let's see. Vertical asymptote comes from the denominator left over. So we have a vertical asymptote at x equals negative 3. Holes come from if anything canceled, and we did. The x plus 1's canceled, so we have a hole at x equals negative 1. And then last but not least, our horizontal asymptote is going to be where the biggest power is. It's down below. So again, since my bottom has the biggest one, he's going to reach up and he's going to hug the numerator. So we have a horizontal asymptote at y equals 0. Okay, now let's start graphing these things. We have 3x over x plus 1. My first step before anything would be to factor, but this one is already simplified and there's no factoring that I need to do. Part A, at what value of x is f of x undefined? So that's asking us what x value would make our denominator 0. So that would make that equal to 0. So if that's not allowed to equal to 0, that means x is not allowed to be equal to negative 1. So what value of x is undefined? When x is negative 1, we are undefined. Part B, identify the vertical and horizontal asymptotes. All right, well, what I just did in Part A helps me with my vertical asymptote. If we can't have an x of 1, we can't touch it. So my vertical line I cannot touch is also at x equals negative 1. Okay. Our horizontal asymptote this time, look for my highest power. They both have a power of 1. So our horizontal asymptote is going to come from our leading coefficients, which are 3 and 1. So it's going to be at y is equal to 3. All right, I'm going to go ahead and graph those on my chart down here. So horizontal is crossing over where y is 3. And then my vertical line is crossing where my x is negative 1. So down here. Okay. All right, let's do a t-chart to show where my values are going to be. So here we go, x, y. And we're going to dance around the vertical asymptote, which was negative 1. So we're going to go a little bit below and a little bit above. So let's go, I don't know, let's go negative 4, negative 3, negative 2. Here's our vertical asymptote. Then go above it, 0, 1, and 2. So again, this squiggle in the middle is showing our x value of negative 1 that we can't touch, so we got to jump over it. All right, plug those in your calculator, and let's see what we get. Remember, when we type it in, parentheses are very important. So for this one, when you type it in, you're going to go to y equals parentheses 3x parentheses, and then divide that by another parentheses of x plus 1. And then don't forget to close your parentheses. So this is how you type it into your calculator. So go ahead and do that and fill in this table. All right, so after plugging in our values, we have points now that we can put on our graph. So we have negative 4, positive 4, so about right here, negative 3 and 4.5, negative 2 and 6. So we know we're in that first, or actually it's 1, 2, 3, the fourth quadrant. My other side, we got the origin 0, 0. We have 1 and 1.5. We have 2 and 2. So there's my other one. Now, we cannot forget, do we have any holes? For number 11, we do not have any holes. Okay? So since there's no holes, I don't have to put any breaks. So I'm just going to go ahead and connect these. Here's my first curve. And here's our second curve. Good, and the asymptotes are what is bending our lines in those ways. All right, we got one more. Here we go. We have 3 over x plus 2. Again, I should factor if I can. This time I cannot. So let's work with what we get. What value is f of x undefined? So again, that makes what would make this whole thing divide by 0? Well, that would be... let's see here. So x, if x equaled 2, that would make it undefined. So x is not allowed to equal 2. Part B, vertical and horizontal asymptotes. All right, vertical asymptote, we just found that. That's going to be at the line of x equals 2. I'm going to go ahead and do that down here. There we go. X equals 2 is that vertical line. All right, our horizontal asymptote. comes from where the greatest power is. And if I look at my function, it looks like the greatest power is down at the bottom. So that means he is going to reach up and he is going to hug our numerator. So our horizontal asymptote this time is at y is equal to 0, which is our x-axis. There we go. All right, do a t-chart. Let's find us some values. All right, let's see. 2 is in the middle. So let's go down. Let's see here. 1, 0. Let's do -1, 0, 1 asymptote. And then 3, 4, and 5. Plug this in. So again, calculator will be y equals parentheses 3 parentheses. Seems silly, but just be in the habit of doing that every time. Parentheses around your numerator, divide, parentheses around your denominator. That way, if you do it every time, you won't make a mistake. All right, so plug that into your y equals or start typing in values, and let's see if we get matching pieces. All right, we got our values. Let's graph them. It did say to include the y-intercept, which I did. It is when my x is 0. So here is my y-intercept. And again, this break in the middle is showing our vertical asymptote, which is at 2. So that's showing the break. All right, let's plot my points. So we have -1, +1. No, it's not. It's -1, isn't it? Yep. Let's try that again, shall we? Boop. So that's in the wrong spot. And again, I noticed that was wrong because I can't jump the line like that. I was about to jump the line to go to my other point, so I knew something was wrong. All right, -1, -1. 0, -1.5. -1 and -3. So there is my first curve. So we know which is in quadrant 3. Which we know the other one has to be diagonal from it, so it needs to be in quadrant 1, which it is. 3, 3, 4, and 1.5, 5, and 1. So we're getting real close to these asymptotes, not touching it. We did not have any holes this time, so we don't need to graph any of those. So we're just going to connect them. There we go. There's one, and there's my other. Remember, you cannot cross those dotted lines. If you do, you will get points taken away. That's the whole point of those dotted lines. You cannot cross them. All right? So, if you have any questions over any of these things, you can remind message me. I can't promise I will answer, but I will try my best. It is Thursday, so I'm not too busy tonight. Just text me and I can try to help you out. All right? Good luck, and Miss Douglas will see you on Monday. All right. Love you guys. Be good. Study hard. See you then. Bye.